So thank you. My name is nice to meet you. Thank you so much for inviting me and to be here today in the session online. My name is Antonio Garcia, and joining with my colleague Arturo Garcia Martinez, uh, we already present the paper titled "Understanding Back Investment in Fossil Fuels: An Approach from Value at Risk and GVM." Uh, both are from the University of Almeria in Spain, and uh, we start to present the work. So this is a brief content and a brief agenda about the presentation about the PPT with an impact and brief introduction, methodology with the sample and data set, and a brief description about the value at risk and the geometry, Brownian motion, the GVM methods. After that, we present and we show you the results uh, between the value at risk and the geometric Brownian motion. So we start with the result and output extracted from the value at risk, and at the end of the result section, we present the GVM output. And after that, we conclude with the main conclusion and the main results and thoughts about this analysis, and with together with the limitation and the future research line. So we start with the impact and the motivation of our results, right? First of all, we wanted to show you a brief graph about the fossil fuel consumption worldwide. This data is from the last report from Energy Institute, and the graph say this: the 82% of total consumption in terms of energy demand, primary energy demand, it's 82% it's from the fossil fuel energy. That's called the carbon, oil, and natural gas. So this is a big problem to with an emergency and with the urgency to take care and to reduce this fossil fuel consumption around our matrix energy demand worldwide. So this is a big problem, a problem from the emission specifically, and we needed to be uh, to do something about that. So one of the main solution and main hope to take on this kind of this sort of things, this kind of problem, is the climate finance, right? So the climate finance is proposed according to the increasing awareness of climate change, and public opinion has become increasingly skeptical about the environmental impact of the fossil fuel industry. And a lot of campaigns also have emerged to encourage banks and other financial institutions to sell their stakes in this sector. So one of the solution that I told you before is the climate finance. The climate finance, the main propose is that uh, redirect the world saving and the world investment from the fossil fuel investment to a low carbon investment, and with lower and try to reduce the risk level of this investment. So this is like our main theoretical framework to that help us to introduce the next session, right? So, which is our main goal in this analysis? Our main goal is compare the risk-return ratio between the financial institution, that say the banks, the global banks, with the different fossil fuel investment policies. So it's something like compare different uh, asset management portfolio in a different situation, right? With different policy according to the divestment effort in each bank. So other goals, right? It's are sorry knowing the future trajectory of this return with the GVM methods and simulate these different performance scenarios, also with the GVM methods. So this is something like we needed to be sure about the risk return ratio that the divestment in fossil fuels give us. This is our main uh, theoretical problem, right? So, which is the our methodology and which is the method that try to to carry out this analysis. So, with about the sample and data set, we extract information and daily returns from 40 global banks, right? Big global banks like JP Morgan, Bank of America, and so on. And we extract a time frame and a period from the 2016 to 2022. This is because the viability data in our dataset, which is our dataset, is the Banking on Climate Chaos, the last report from this organization, right? So we can extract just 6 years, right, from 2016 to 2022, and we use that I told you before uh, two main two main methodological approaches, right? One of them is the value at risk. The value at risk would measure the loss that could be suffered under a normal market condition in a time frame and with a certain level of probability or confidence, right? So we try to know which is the maximum loss that the different portfolio that we analyze uh, have around the time period, right? This is our first approach, just to say which is the portfolio with the best risk return rate. And the other part is the forecasting this performance. So to do that, we use the geometric Brownian motion. The GVM assumes that a constant risk is accompanied by random shocks. While will the period return under GVM and normally distributed, the consequent multi-period, for example, 10 days, price levels are log normally distributed. So it's something like try to guess the future situation, the future performance of an exact and specific portfolio. So you're right. We can start with the result section, right? So first of all, we differentiate the research section in for one side the value at risk and the other the GVM, right? So for the value at risk, we can extract the main output. In the end, the main output is the this maximum loss that the portfolio uh, can, can can have, right? Can have. So we have on the one hand, on the one side, the fossil fuel portfolio, and from the other, not the non-fossil fuel portfolio. So if portfolio constructed by a big bank that not the divestment at all in this kind of fossil fuels, the maximum loss is 4.7%. And with the portfolio formed by the big bang that try to divestment more in fossil fuels, the maximum loss is 5%. So, which kind of conclusion we extract of that? That the main conclusion is that the fossil fuel portfolio present a better situation, a better performance according to the value at risk. That say, according with the relationship with the risk and the return. So this is the first output. And the other output is the GVM. So the try to forecast the future performance of the portfolio. So you can see here, we can try to move my mouse, right? Uh, Here there is the fossil fuel portfolio. You can see like when you sorry when you when you invest $10,000, we can demonstrate or we can present the different situation that according to the GVM, the performance can have, right, in the future. So here you can see like the most of the cases in the future performance, it's in a positive side, right? So you can see here all the possible situation, all the possible performance of the portfolio. It's in the positive side, right? This is according to the fossil fuel portfolio. And the other part, the banks that try to divestment more in fossil fuels, you can see here the future situation, the forecast. Here, the forecasting is something like the 50% with the cases in the positive side, and the other 50% more or less with the future performance in a negative way. So the main conclusion that we can extract here is that the fossil fuel portfolio is uh, it's more profitable according to the GVM, right? And it's less volatile between the fossil fuels and compared with the non-fossil fuels. And here, the non-fossil fuel, you can see like more or less a 50% is from the positive side, and the other 50% is for their negative side, right? So uh, we finish here with the principal conclusion, right? That I tried to say before. The fossil fuel portfolio has a lower value at risk, has a lower risk at the end of the day, and is predicted to outperform the non-fossil fuel portfolio, right? Uh, and this analysis is not perfect for sure, so we can present some limitation here. So the principal limitation, I think that this is the sample that we use. It's something like limits, right? So the sample can be larger for sure, identifying other financial entities such as investment fund, pension fund, ETF, uh, sovereign funds, and so on, right? And for that, the future research can be moved by the identified explanatory factor for divestment, for example, for instance, in fossil fuels and make a comparative study by country. Why? Because probably there is a lot of legislation that is a difference between the region and the country, and probably the different portfolio performs in a different way, right? According or impacted by the specific legislation and regulation of the region or another country, right? So this is all. If you have any cure, you have any ask question about that, can you reach me on by email or by LinkedIn? Uh, thank you so much. That's it's all. It's a pleasure for me, also for Professor Arturo Garcia, and see you soon. Thank you so much.